Hello engineers, welcome to GAL Consult. This will be the second part of our tutorial series on electrical accessories. Being a function of an electrical building services engineer, if you have not watched the first part, please click on the link above or through the comment section below. Today's tutorial will be mainly practical, using a project as a case study. Keep studying. Before I proceed, I did like you guys to understand that switches falls under electrical lighting system design, while sockets fall under the power design, but both designs must have the following content. 1. The reference drawing. The reference drawing, which is the architectural drawing, we'll be using this project as a case study. Here is the floor plan, the ground floor plan. Here is the first floor plan, and here is the roof plan. Here are the elevations and the sections. Here are the 3Ds. Although, while using Autocad software, the main consideration is always the floor plans, but you can also have the other designs for perusal and to ensure coordination. So we need to take the floor plans in this project out and start with our designing process. The second content of accessories design is the general instruction. The general instruction is a page on every electrical design that will explain how electrical technicians must comply with your design. So for this project, here are my general instructions. I stated that 13 amp socket shall be wired in ring mains, that is the ring circuit method I explained earlier, using a 3 by 2.5 meter square PVC cables, and be protected in a circuit with 30 ampere MCB, miniature circuit breaker. That means our circuit will be a 30 amp circuit and the wiring will be a 2.5 mm diameter wire. Moreover, my 15 ampere socket shall be wired using 3 by 2.5 mm PVC cable also, and be protected in circuit with a 30 ampere miniature circuit breakers. This simply means the instructions I specified for electrical technicians to use and must comply with is that I will be having a 30 ampere circuit, ring circuit, and the cables to be used shall be of 2.5 mm diameter. The third one is the legend. As I said earlier, that switches falls under electrical lighting design, while sockets fall under electrical power design. And I've also explained that legend is the first thing electrical supervisors or technicians will look at in your design is basically the symbolic representation of accessories used in the project. Here is my legend. For my switch, I'm having this symbol representing a 5 ampere 1 gang one-way switch, as I've explained gang and ways. 2. Symbol E2. Here is the symbol. It represents a 5 ampere 2 gang one-way switch also. I have this symbol which represents a 5 ampere 1 gang and a 2-way switch. I have this symbol for my dimmer switch, which is also a 5 ampere and a 1 gang. We also have this symbol representing either a 13 ampere or a 15 ampere single pole. I've already explained single pole and double pole. Single pole switch socket outlet or receptacle, and this for a single pole also, but a twin receptacle. We have 2 outlets on a single panel here. So we still have this symbol which simply represents either a 13 ampere or a 15 ampere, but it is a weatherproof outlet, weatherproof socket, which is one of the type of sockets we've explained earlier. Moreover, I have this symbol which I use to represent a 20 ampere, which is also a weatherproof power socket outlet. So this is of 2 types. It will be a power outlet as explained earlier, and it will also be a weatherproofed, that is IP protected, ingress protection. This symbol represents a 15 ampere single socket outlet. It will be IP54, which means it will be weatherproofed also, flush mounted with an on and off switch for extractor fans. We still have this, which will be at high levels. It's just a combination of the 2. Here are the basic things an engineer must specify. For example, here I stated it clearly in my legend that this project, that anywhere I'm having this symbol, the fixtures must be placed at an high levels. I still have other outlets that will be later discussed, which include a 20 ampere water heater outlet and a 45 ampere cooker control unit. Cooker control unit is also a power outlet. Likewise, hot water heater, I still have a 45 ampere outlet which is to be used for my jacuzzi control. I still have an outlet for my connected box, which are being rated in 20 ampere. Thus, the third content for every electrical accessory design is the legend. The fourth content is the design layout. I mean, how my legend are being laid in the project. For my project here, my switches are located in my lighting design, while my sockets are located in my power designs. So here is my lighting design. After I've distributed my lighting fixtures and I've run my circuit, they need to be connected to a point. Thus, I will need an electrical switch. Here is my switch that is connected to this circuit. 4 lighting fittings. This is how switches are distributed throughout the lighting designs. Here is another office having these fixtures connected to these switches. Likewise here, located outside of the toilet and the bedrooms. Every electrical lighting system circuit must be connected to my switch. Then from my switch, the circuit line will then be run to the distribution board. Here is how sockets are being distributed. For my office here, I'm having a socket here, another one here, another one here, and I'm having one here at eye level as already specified in my legend. Likewise, my outlet for my AC here. In my bathrooms, I'm having an outlet for my extractor fans, and in here I'm having an outlet for my hot water heater. The next content in every electrical accessory designs is the panel identification. You must have observed throughout this layout there is always a number close to all my fixtures here. For example here, 13 or 15 ampere outlet, single socket outlet. But here is my panel identification, which is specifying that this outlet is to be run to my A2 circuit, and the one here is to be run to my A3 circuit, here to my A3 circuit also, here to my C2 circuit. And for the switches, after I've distributed my lighting fixture and I've run my circuit, the cable is directed to my electrical switch, which then goes to the distribution board. For this my switch here, the panel identification is E1. Panel identification, as I've said earlier, are always alphanumerical codes. You will observe I'm having some switches with the same panel identification number. Like this, the switch controlling this circuit is identified as A1, while the one controlling these fixtures also as A1. This simply means my switch here and my switch here will be connected to the same circuit. Likewise, for the power design here for my socket, I'm having D3 here. I still have D3 here. I'm having D10 here. I'm having D3 here. I also have D6 here. It simply means my fixture here and the fixture here at eye level, the fixture here and the fixture here are to be connected to my circuit D3, which the amperage will be restated, while the one here, connected box for AC, is to be connected to my circuit D10, while the one here is to be connected to my circuit D6. And this fixture now, I will have to go back to my legend. What does it represent? In my legend, I stated it here that it should be a 20 ampere weatherproof power socket. Then we'll have to go to how our panels are being arranged. Let's take this panel as a case study. As I explained in my lighting system design, we're having only a single circuit for my lighting system and to be wired with 1.5. But for my 13 ampere socket or my 15 ampere socket, we have this circuit, which will be G2, circuit G2, because this is a distribution board GA. So it will be my circuit A2. I've already stated that my DBGA represents my DBA, which is situated in my ground floor. So that's why we said anything about panel identification is just an alphanumerical code. So that means this is my distribution board A, my circuit A2, because we're having the circuit number here, my circuit A2, which is a 30 ampere circuit, okay, will be in my yellow phase. That's the second phase. We'll have a 2.5 mm square cable and I'm having a 13/15 ampere socket in it. My circuit here is for fan, which are also an accessories. So we still have another one here which are for my AC. They are majorly a power outlet. Likewise for AC and my Autocad. My distribution board here is a 25 ampere TPN isolator board. In a nutshell, the fifth content for every electrical accessory design is the panel identification. Then we'll have the installation details. For example, here, this is how my socket will look like. This is how my 13 ampere socket will look like, and my 15 amperes. This is how they will look like. This is a type 30 volt 30 ampere switch socket. These are two gang sockets or twin sockets. Of course, that of the switch. I'm not having the switch here. So in my installation details, I specified the height. So I specified 1400 millimeter for them, and the one at the low level I specified 200 millimeter for them. So that's how an installation looks like. Anyway, hope you find this tutorial helpful. Comment below please, and don't forget to like and subscribe. See you next time.